All right, let's go ahead and get started with our lesson. My name is Miss Argueta. You should all know that. You guys are all my followers. Here is lesson 69. That is page 489 on your book. Make sure you turn to that page while you're looking at the video. This is going to be kind of long, so let's go ahead and follow along. This is with complex numbers. Complex numbers is a combination of real numbers and imaginary. Real numbers are what A is. Imaginary is like 7i, 12i, 13i, anything like that. So A plus BI, that's a standard form for complex numbers. Also, when you're doing coordinates, this also applies to the coordinate graph. A is considered your x coordinate, and then B is considered your y coordinate here. So now we are going to solve each one of these out. Here, 3 plus 4i. Your A is your x coordinate, so that means your x would be 3. 4i would be your y coordinate, and you're only focusing on the number in front of the I. So your coordinate for A would be 3, 4. Your coordinate for B, your A is considered your x, so your x is -2, your y is -3. C, -4i. A is considered the complex number. In this case, it's just -4i. There's no A, so that's going to be 0. Your B is considered -4. Here we have D, which is 1. So 1 is considered a real number. That's going to be your A, which is also your X, so it's going to be 1. There's no imaginary number here for the plus BI. That's going to be 0. If you need help on how to graph these, this is how I have it here. You can pause it there, but I have it all graphed there and how it should look. Example 2. Now we're going to go ahead. Never mind, I was wrong. All right, example 2, now we're finding the distance. If we look down here, we're gonna deal with a coordinate grid, meaning we're finding the distance between the A plus BI to 0. To find that, we have to do the absolute value of the complex number is equal to square root of A squared plus B squared. That goes back to the distance formula. So I'm gonna go ahead and write the formula first. So A plus BI is equal to the square root of A squared plus B squared. Here we have the absolute value of 3 plus 4i. That is equal to A, which is your first term, which is 3, plus your imaginary number, which is 4 squared. We're not going to do anything about the I just yet. Now we go ahead and simplify. We got 9 plus 16. That is equal to the square root of 25, which is equal to 5. Next one, -2 minus 3i. Again, it's A plus BI. This is equal to A squared plus B squared over the square root. We have -2 minus 3i. So our first term, our A, our real number is -2, so it's -2 squared, plus our imaginary number is -3i, and we're just focusing on the number in front. We have -2 squared plus -3 squared all over the root. So -2 squared is 4, 3 squared is 9. So we get the square root of 13, and then you can just leave it there. You can't simplify. If you can, you will simplify it, but in this case, we can't. Next one is -5i. Again, we still have to apply that A plus BI is equal to the square root of A squared plus B squared. Here, we don't have an A. It's just -5i. We put 0. BI is considered -5i. So you need an A, you need a B at all times. Now, my first term, my A is considered 0 squared, and my second term is -5 squared. Now we go ahead and simplify even more. 0 squared is 0. -5 squared is positive 25. This gives you the square root of 25, which is equal to 5. So keep in mind there is an A here. There's always 2 terms for these type of numbers. Next one, example 3. Now we're going to go ahead and multiply them. Here we're using the distributive property and going to multiply this out. Now we learned that I squared is equal to -1. That's why in this case the I kind of disappeared, because you're kind of squaring it, so there's no point there. So now here we have the I squared is equal to -1. If we multiply this out, we get -28 minus 12i squared. So we have -28i, let me include that there, minus 12i squared. Here we can't add anything together, but the I squared is equal to -1. So now in place of I squared, I put -1. So now I have -28i plus 12. And they say to write your terms in A plus BI, meaning your real number first, your imaginary number second. So for this, it will be 12 first, and then minus 28 second. So I just flipped them because they want the real number first. B, now we have to do distributive property, or sorry, FOIL. Here we have 5 plus 4i times 6 minus 2i. We do 5 times 6, just 30. 5 times negative 2i is negative 10i. 4 times 6 is positive 24i. And then 4i times negative 2 is minus 8i squared. Now, from this point, you add like terms, just like x and x squared. We have 30. We can combine this here. We get plus 14i. And then we get negative 8. We have this I squared. I'm going to replace it with a negative 1. Now, if I simplify it more, I get 38 plus 14i plus 8. And then combining terms together, this is 30, it's going to be 38 plus 14i, and that's your answer. A plus bi, it has to be in that format. Another thing you need to know is the powers of the I. So if we have one I, that's just equal to I. We have I squared. We set it right here, that's equal to negative 1. So this automatically turns into negative 1. If we have I cubed, I know I have an I squared and I have one I left over. I know that the I squared is equal to negative 1 times your I. So that means if I multiply all together, I get negative I. I to the fourth, I know that if I divide the 2 into it, I have 2 pairs of I squared. So now I have I squared times I squared will give me negative 1 times negative 1, and this will give me a positive 1. And in your book, it has different examples. The reason why we need to know this is because we're going to start solving when the i's have very high exponents. But now let's look at this rule here. According to the book, they say whenever you have a remainder, so you're going to be dividing by 4 for the exponents only. You're going to divide the exponents by 4, and whatever your remainder is, you're going to put I to whatever your remainder is to the power of that. Now let's do example 4a. Let's see what I mean. First, you divide by 4. So I'm just going to focus on the 30. 30 divided by 4 is equal to 7. But 4 times 7 is 28. So what's my remainder after I divide? 2. And that 2, that is going to be your remainder here. So this is a way to solve for it instead of doing 2 pairs of each one and finding it. This is just a faster way. So now I have 30. I always divide by 4 every time. I have 7, but I always have some type of a remainder, whether it's 0, whether it's any type of number. And that remainder is 2. Don't look at your calculator and put 0.4 because the calculator will tell you 7.4. It's 28. 7 times 4 is 28 with the remainder of 2 to get to 30. So it's I squared, and I squared, if I remember, I go back here, I squared it always equals negative 1, and that's your answer for A. B, you have negative 2 times I to the 13th power. Let's focus on the exponent. We do 13, let me move the camera, 13 divided by 4, and we get 3, but we also have a remainder. 4 times 3 is 12, our remainder is 1. That means you're going to have negative 2 I to the 1 power. And I to the 1 power, if you look up here, it just gives you basic I. So your answer here, you're going to multiply it with your number in front, it's just going to be negative 2I. Let's go ahead and do C. C is different. Let's see what I have here. I didn't do B, that's why. Okay, so for B, it's 5I to the 12th power. So these are just switched. Okay, now here 5I to the 12th power, so I know 12, I have to divide that by 4 every time, and I get 3. If you notice, that's a perfect number because 4 times 3 gives you 12, but my remainder is 0. I don't have anything as a remainder for that. So here, if I put 5I, I always have to put the remainder here. The book has something different, but your number, your remainder is always your exponent, so it's going to be I to the 0 power. If we remember, anything to the 0 power always equals 1, and that's why our answer is 5. Example 5, this is the very last step. Now we're dealing with conjugating. So we conjugate radicals, but we also conjugate the i's. So here, we have 3 over 6 plus I times radical 5. It says divide 3 by this. The number you divide first always goes on top. The number you divide second goes on the bottom. Here we have to conjugate. So there's a radical and an I in the denominator. I'm going to go ahead and try to get rid of that. So remember, we do opposite signs. 6 plus I radical 5. Then you're going to multiply the top and bottom by 6 minus I radical 5. Now, if we go step by step, let me go this way. We do 3, let's go look at the numerator. It's 3 times 6, which is 18. And then you do 3 times negative I radical 5. That would be minus 3I radical 5. So remember, you're distributing. The bottom here, so I'm going to focus on this section here. If we multiply these two out, it's like just like what we did over here for B. You multiply it all out. 6 times 6, 36. 6 times negative I radical 5 is negative 6I radical 5. I radical 5 times 6 gives you positive 6I radical 5. And then I radical 5 times negative I radical 5. This will give you a minus I radical 5 squared. Or if you remember, the terms are the same. It's in terms of A squared minus B squared. You square the first term minus squaring the second term. That also applies too, but if you don't remember how to do this, you can simply do this. I'm going to go ahead and finish it here. These two cancel out. Plus or negative 6I radical 5 plus 6I radical 5. Those two are exactly the same. Opposite signs, they cancel out. Now we have 36 minus, here we have I radical 5. You're squaring two things between the parentheses. You're squaring the I, but you're also squaring the radical 5. So when we square the radical 5, that cancels out. And we have 36 minus 5 times I squared. Also, the I squared is equal to negative 1. So this gives you 36 plus 5. And your answer here, 41. Go step by step. If you apply it this way, this will give you the same exact answer. So we have this over 41. In your answer, they want it in terms of A plus BI. That means the I, they want it in the very end. To make a fraction here, you divide it. So there's two terms on top. There's a 41. So you're going to have your first term over the denominator. The sign here is minus. And your second term, 3 radical 5 over the same denominator. The I, the reason why I didn't put the I there is because they want it in the very end. So that's how you'll have your answer. If you put it in front of the I, that's wrong. B, same thing here. We have to get rid of the I, just like how we have to get rid of the radical here. We don't have it where it's in terms of adding or subtracting, but we have just 6I. We just do the opposite signs. So we're going to multiply the top and bottom by negative 6I. If I do that, I have here 4 plus I times negative 6I. I have to use distributive property. So now, negative 6 times 4 is negative 24I. Negative 6 times I gives you negative 6I squared. The bottom, negative 6, or 6I times negative 6I, 6 times 6, negative 36. I times I squared. And then we keep on simplifying here. So I'm going to bring it over here. We're going to have negative 24I minus 6I squared. We know that I turns into negative 1 over negative 36. And then we have also another I squared that turns into negative 1. Now, keep on simplifying it. We get negative 24I plus 6 over 36. Here, I'm going to move it around because we always want it in terms of A plus B. So for the top, I'm going to move it around to 6 minus 24I over 36. They want it in terms of A plus B. So A plus BI, I get 6 over 36 minus 24 over 36I. This can be simplified. It keeps cutting off because I need to make more room for storage. Ugh. Now, we're going to go ahead and simplify this for the last answer. 6 over 36 is simplified to 1 over 6. Negative 24 over 36I, just simplify in your calculator. Either find the common term, or if you just put in your calculator as 24 over 36, it will simplify it for you, and you get 2/3, I believe. Yep. 2/3i, and that is your answer there. If you have any more questions, make sure you go on the drop down, look for my email, and type me up. Thank you.